This is another one that you're going to see quite a bit of in your future math classes. I know it gets used in Calc 3 and differential equations all the time. So this is back to that u substitution kind of setup. So I do need to use u for my exponents. We're going to say let u be that 10x, so that what we're integrating over here is e to the u. Let me finish out the dx and du portion. So that tells us that du is 10 dx. So I am missing that 10 and we'll divide it. So du over 10 is our dx value. And so I'm going to write 1/10 out front and du right here. So we've done things really, really similar to this in the past. So when we integrate this, we end up with just e to the u plus c, and I have 1/10. And you know what? I haven't really been emphasizing this as much. Technically, this 1/10 does apply to the group, right? Because it's 1/10 times the integral. But the thing is, so we do get 1/10 e to the u. 1/10 of c. C is just some arbitrary constant, right? It's meant to be a placeholder more than anything else. So technically what's happening, again, kind of behind the scenes, is we say something like, we'll just let C1 be equal to 1/10 of whatever that C value was, and you end up with the exact same thing, an arbitrary value of C. So technically, yes, it is distributing. I've kind of been neglecting to write that down. And it's just because C can be any number. We're not solving for it. This is not a particular solution. There's not really a need to know what it is. It's just an acknowledgement that there could be a constant there. So this is not typically written out, although if it is, I want to make sure you've at least seen it and have an understanding of what it is. I am more than fine if you just jump straight down to, and you don't even need this if you don't want it, the C1. You can just call it C. But in the back of your mind, it is worth kind of having this knowledge. Technically, you distribute 1/10 of something arbitrary is just something else arbitrary. I will substitute back in though, and so I would have e to the 10x over 10 plus c. And again, this is a really great one where we can practice our differentiation to kind of check that this works. So if you said dx of e to the 10x over 10 plus c, well, we know the derivative of e is itself, so we would get e to the 10x, it's still over 10, right? Times the derivative of that 10x, which is a 10, and then my c becomes a 0. These cancel, and you can see we're just left with e to the 10x, which matches with what we got up above.